Okay, so the last video finished up through the one-step problems with stoichiometry. This one we're going to start with 2 and 3-step problems. So let's write 2 steps. If you begin the reaction with 2 grams of aluminum oxide, so 2 grams of aluminum oxide, how many moles of oxygen will you end up with? So let's make sure we label 2.00 grams and how many moles. Okay, so we start by writing the given, 2.00 grams of Al2O3. The first step is get to moles, and we're going to do that by using the mole map. So the words on the top are the words on the bottom, so grams of Al2O3. And we find the molar mass, which is 101.96, and I'll write molar mass. Make sure you know. We get that from the periodic table, and this is 1 mole of Al2O3. Okay. Then the words on the, the second step of stoichiometry is the mole ratio. Okay, and we use, it's always the unknown over the given, and we use the coefficients. So the words on the top are the words on the bottom. So mole of Al2O3 to moles of my unknown, which is what I put a question mark, so O2. We have 3 moles to 2 moles. Okay. The third step is get to my unknown. And my unknown is moles. I'm at moles, so I don't need that step. So we'll just hit enter. We multiply across. 2 times 3 is 6, divided by 101.96 times 2, which is 203.92. So when we do that, we're going to get 2.94 times 10 to the minus second moles of oxygen. Okay. If I'm going too fast, please slow it down and rewind it and practice this as many times as you need to. All right, the second step, I really actually encourage you to pause this, try this reaction out on your own, and then come back. The reaction ended with 23.7 moles of aluminum. 23.7 moles of aluminum. How many grams of oxygen? So, question mark, grams. Okay, what did it end with? So I'm going to start by 23.7 moles of aluminum. All right, the first step is get to moles. All right, I'm already at moles, so I can go ahead and go to my second step. Let's go ahead and write already at moles. Okay, and so we're now going to use the mole ratio. So the words on the top are the words on the bottom. So mole of aluminum, and there are 4 moles for every 3 moles of oxygen. Okay. The third step is get to my unknown, and we're going to use the mole map. So the words on the top are the words on the bottom. 1 mole of oxygen is equal to how many grams of oxygen? That's my unknown, and it's 32.00 because 16 times 2 is 32. We multiply across and we divide by the bottom. So we get 2,275.2 divided by 4, which will give me 5.69 times 10 to the second grams of oxygen. And that's your final answer. Okay. Example 3, as you probably figured out, is a 3-step problem. Okay, apologize for my phone there. All right, if you begin the reaction with 14.45 grams of aluminum oxide, 14.45 grams of aluminum oxide, how many grams of aluminum would it end with? Question mark, grams of aluminum. Okay, so we always start by writing our given, 14.45 grams of aluminum oxide. The first step is get to moles. I am not at moles, so I've got to get to moles. Step 1, get to moles. And we do this on the mole map. The words on the top are the words on the bottom. So grams of aluminum oxide is 101.96 grams is 1 mole of aluminum oxide. Okay. So the second step is mole ratio, which is always unknown over the given, and we use coefficients. The words on the top or the words on the bottom is mole of Al2O3 to moles of my unknown, which is aluminum. So it is going to be 4 to 2. And my third step is get to my unknown. Am I at my unknown yet? No. I'm at moles. I got to go to grams. So for every 1 mole of aluminum, there is 26.98 grams of aluminum. Okay. We're going to multiply across. I'm going to have to put that up here. And we're going to get 1,559.4 divided by 203.92. Okay, we do the math and we get 7.65 times 10 to the 0, or you can just say 7.65 grams of aluminum. Final answer. Okay. All right, let's go over to the back. Go ahead and pause this video so you can practice this 1 3-step problem on the back. And so let's work it out. So it says that the reaction ended with 21.9 grams of oxygen. 21.9 grams of oxygen. How many grams of aluminum oxide did the reaction? Say question mark, grams of aluminum oxide. So we start with our given. 21.9 grams of oxygen. Okay, the first step is get to moles. And we do that by using the mole map. Okay, the words on the top are the words on the bottom. So grams of oxygen, this is going to be 32.00 because 16 times 2 gives me 32. It's 1 mole of O2. All right, the second step is going to be the mole ratio, and we get this from the coefficients, and it's always the unknown over the given. The words on the top are the words on the bottom, so mole of O2, and as we know that's my given. So 3 moles of O2 for every 2 moles of aluminum oxide. Okay, then we got step 3 is get to unknown, and we're going to use the mole map. All right, the words on the top are the words on the bottom, so for every 1 mole of aluminum oxide, there is 101.96 grams of aluminum oxide. Okay, moles of aluminum, moles of aluminum oxide, moles of aluminum oxide. Moles of oxygen cancel, moles of oxygen. Grams cancel, and I'm left with my unknown, so I know I've set it up right. I multiply across and I get 4,465.8. Multiplying everything across the top, and I divide by everything across the bottom, divided by 96, and we get 4.65 times 10 to the first, which is also 46.5 grams of Al2O3. Okay. All right. Stoichiometry can also be used for volumes of gas. We have STP, which is 0 degrees Celsius at 1 atmosphere pressure, because this stands for standard temperature and pressure. Okay. We will learn what to do when not at STP, and that's when we go into gas laws that will start on the 23rd. Okay, so if we decompose 40 grams of aluminum oxide, what volume of oxygen? We need to know that volume units are the liter. Okay, so we're going to put question mark liter, and we're going to write 40 grams of aluminum oxide. Okay, so we start by writing the given, 40 grams of aluminum oxide over 1. The first step is get to moles. Okay, and we use the mole map. So the words on the top or the words on the bottom is 101.96. This is 1 mole of aluminum oxide. All right, the words on the top are the words on the bottom, and this is my mole ratio. And I use the coefficients, and it's always the unknown over the given. So, mole of aluminum oxide, and I have 2 moles for every 3 moles of oxygen. Okay. Step 3 is get to my unknown. All right, and this is going to be the mole map. The words on the top are the words on the bottom, 1 mole of O2, and this is going to be 22.4 liters of O2. Okay. Oops, sorry. All right, do the math, multiply across, and we're going to get 2688.0 divided by 203.92, which equals 1.32 times 10 to the first liters of oxygen. This is also 13.2, same thing. All right, if we look, we see a skeleton equation. We see that we have 1 mole in every equation. Then we have mole, and 1 mole. Okay, so when we're, and this is always my given, and this is always my unknown. Okay, so if this helps you memorize it, you could do that as well.